So we're going to start looking at chapter 8, obviously after chapter 7. So today's video is just about an introduction to chapter 8. So here's what we can do. We can see from our textbook that we're going to do in chapter 8, sections 8.1 to 8.6. So we're going to start out with an introduction to that in our notes today. So as we can see here, chapter 8 is all about graphing quadratic functions. And I just reminded you of how we write quadratic functions. ax squared plus bx plus c. Now, just as a reminder, a cannot be 0. If there was no x squareds, then we'd only have something with x's or maybe numbers. So that wouldn't be quadratic. So just remember that we have to have x squareds, but it's okay not to have any x's, or it's okay not to have any constants. So we've seen those before. Now what we're going to start by looking at today is just understanding what the shape of a quadratic function is. So here I have a ton of different examples of quadratic functions. The first thing that we should note for all of them is their general shape. The general shape is a U, and that is a parabola. So we're going to define that word right now. So this is the U-shaped graph of any quadratic function. Now what we can see is a few different things about those. Sometimes they open up like this, in which case I'll use the language. Sometimes I might say up like a cup. You can consider that a smile. I'll use that language. We can see some of them, like this one, open down. This one here opens down. And we might say that's down like a frown. Just so we have some language. Now we can see some of them, like looking at this example, some of them are skinny. Some of them are wide. Some of them open up, some of them open down. Some of them are centered here, some of them are centered over here. So there's a lot of different variations. What we can see here is there's actually an infinite amount of different parabolas that we could draw. Or in other words, we could say it if I wanted to pick any A, B, and C value, we could pick anything. So we're going to look at the most basic parabola today so we can start learning more about the graphs by just focusing on one of them. So what we're going to do first is we're going to look at the parent of all parabolas. So the equation f of x is equal to x squared. Or you might want to see that as y is equal to x squared. That is considered the most basic quadratic function. I'm going to write it over here, again, just one more time in a different way. This would be plus 0x plus 0. So we can see why it's the most basic function. If we have to choose a value for a that can't be 0, 1 would be the most basic number. And then for b and c, to make it easy, we don't have any b's and c's because those are allowed to be 0. So we're going to get to know this function really well and memorize some facts about it today. So the first thing we want to do is to complete the table to create the graph. Now we know it should be a U-shape, but we want to be able to make sure we can do these by hand rather than just using a calculator. So if my input value is x, they want me to put that x value into the function. So if I input -3 in for x, what I have to do to get the output is I need to take that x value and square it. So -3 times -3 is positive 9. So we have the point -3, positive 9. Moving on to the next one, if I plugged in -2 into my function, the rule tells me to take that x value, which I've decided to be -2, and square it. So -2 times -2 is positive 4. If I plugged in -1, I would take -1 and square it. -1 times -1 is obviously just 1. If I plugged in 0 into my function, if I took that 0 and I squared it, I would get 0 back. If I plugged in 1, the function's value at 1, I would take that 1 for x and square it. 1 times 1 is also equal to 1. If I plugged in 2, f of 2 would be taking that x value of 2 and squaring it. 2 times 2 is, of course, equal to 4. And finally, we're just going to do 3. f of 3 is equal to 3 squared, which would be 3 times 3, which is 9. Now that I've plotted those points, I know how to connect the dots. Because when we connect the dots with the appropriate shape, since we know it's quadratic, we're connecting the dots. That quadratic is a U. So I need to connect these dots with a curvy U. Oh, that was kind of a bad curve. Now what I'm going to do at the end of this graph is I'm going to put arrows. Now what these arrows mean, this pattern continues forever. Because in my table, I only had, 7 values there? 1, 2, 3, 4, 5, 6, 7. I could have done anything. I could have plugged in 4 and gotten an answer for 4, or I could have plugged in -4, but there's too many, so I just picked a couple of them. So the arrows mean that that pattern is going to continue forever. So what you have on the next page, this is our parent function. This is the basic parabola x squared, whether you call it f of x equals x squared or y equals x squared. Now what you guys have in front of you is you have a ton of vocabulary words. So we need to learn all these vocabulary words in context of our parent function. So the first vocabulary word that we have is the vertex. Now the vertex is just the turning point of the parabola. Could be the lowest or the highest point of the parabola. You can read that definition there. So if we go to our parent function, the first thing we need to identify is where is the vertex. Now the vertex is that turning point. So I can see right there, that's the lowest point of this parabola. So the vertex of the parent graph is at 0, 0. And as it says here, it could be the minimum or the maximum. Well, that's the lowest point, so we're going to say this is a minimum value. Our next vocabulary word is the axis of symmetry. Now what that is, it's a vertical line that divides the parabola into two symmetric parts. And we understand that symmetric is like a mirror image. Two equal halves, however you want to think about it. So coming back up here, I can see that I have a lot of repeats of numbers, right? At -3, I get a +9, but at +3, I also get a +9. I can see this this y value of 4 right here. There's another y value of 4 over there. Then there's a y value of 1 that repeats, and another y value of 1 that repeats. So what we can see is that this parabola is symmetric. So the axis of symmetry is the line that I would draw to cut this image in half. So right here, this line is the axis of symmetry. Now I made it dotted because it's not actually part of the graph. We just want to see it. So for instance, if I were to fold this part of the graph over that line, it would match up that other part exactly. Now what we know about the axis of symmetry is always a vertical line, and we can always write the equation of a vertical line. So in this case, a vertical line is in the form x equals, and what x value is this vertical line going through? Well, it goes to the point 0, 0, so the x value is 0. Now roots, zeros, and x-intercepts, those are just all the same thing. So the roots are the x-intercepts, the zeros are the x-intercepts, and there's a lot of different definitions, but what we can see here is that it's the x values which we get the output of 0, or it's the point where they cross the x-axis. So the x-intercepts of this graph, or in other words, the roots of this graph, or in other words, the zeros of this graph, what x value would we plug in to get an output of 0? Well, if I look at my table, the only value that I plugged in to get an output of 0, so remember inputs and outputs, the only number I would plug in for x to get 0 was 0. So the only x-intercepts or roots was at x equals 0, or we could say the point 0, 0, right? So this right here, this is our x-intercept, that is a root, it is also a 0. They're all synonymous. So in this case, the vertex and the x-intercepts are the same point. Now we've seen that before elsewhere, like for instance, something like this one here. The vertex is the lowest point, but the x-intercepts are not the vertex. So we can see that fact is special to our parent graph. The next really important word obviously is the y-intercept. Where does it cross the y-axis? We already know that. In this case, it's actually the same point. The y-intercept, where does this graph here cross the y-axis? It's at 0, 0. So the x-intercepts and the y-intercepts are the same for the parent graph. That's why we call it the most basic parabola. Now these next two words are probably new to us. We want to describe how the graph looks. So increasing, that's a way that we would describe a graph. So a graph is increasing if the y values are increasing as the x values are increasing. A function is decreasing if the y values are decreasing when the x values are increasing. What we can see here is if we start on the curve, so if we're on the graph, we read from left to right. What is the y value doing? So if I started right here on my curve, and I started going down that curve, what I can see here is like this point has the x value of -3 and the y value of 9. This point has the x value of -2 and the y value of 4. This one has the x value of -1 and the y value of 1. So I notice that the x values are increasing. But as the x values are increasing, my y values are decreasing. So our parabola is decreasing on the left side of the axis of symmetry, right? If I'm anywhere on this curve, my y values are always going down. But as soon as I get over to this side, I can see that as the x values increase, so do the y values. So my parabola is decreasing when the x values are less than 0, and it's increasing on this side of the graph. If I followed the graph from left to right, it would be increasing when x is greater than 0. And as we can see down here in the definition, when we're describing a function to be increasing or decreasing, we are giving the x values on the graph where it's true. So if we picked an x value that was bigger than 0, let's say something like x equals 1. So if I go to the point on the graph where x is equal to 1, I told the reader that it was increasing there. So if it is increasing at that point, if I start to move left to right on the graph, my y value should be going up. So if I started here and I moved left on the graph, my y values are going up. Similarly, if I picked an x value that was less than 0, like -2, if I started at that x value of -2 right here, and I move on the graph from left to right, my y values are going down. Now the last part about today and the last fact of our parent function is the domain and the range. So we're going to look at this two ways. So the domain is all of the inputs into a function. So if we think about the domain, our function is f of x is equal to x squared. So our input is x, and I'm going to square it. If I asked myself, what are all the x's that I could put into the function? I'm asking myself, what x's can I square? Well, any number. If you pick a number, I can square it. So our domain is all real numbers. Now let's look at that on a graph. We can also see the domain and the range from a graph. On a graph, it's all the x values that could be plotted. So if I start following these points, what x value is on my graph? Well, all the x values, if I start here, this is 0, all the numbers to 1, 2, 3, 4, 5, 6, 7. It's going to keep going forever. If you pick an x value, there's going to be a point on my graph. Like if you pick the x value of 2, there's a point on my graph that has that. If you pick the x value of 2.5, like 2.5 is right here, there is a point on my graph that has that x value. Maybe you picked 3.6. Well, 3.6, that x value is like right here. That's somewhere on my graph. Even if you picked an x value of like 150, it's not on my graph, but it could be, right? If I were to add it to my table, could I square 150? Yes. So what numbers could I put into my function to be squared? It could be anything. Now the range is what you get out of the function. So if we think about the range of this function, is the answers after I square it. Or we can think about it, all the y values on the graph. So let's do it by a graph first. If I looked at this graph, if I look at the y values, there's no y values that are lower than this, and this is the y value of 0. All my graph is above that y value of 0 or exactly equal to 0. So what are all the y values on my graph? Well, the range would be all the y values that are bigger than or equal to 0. I'm just going to make that a little more clear as our range. Now, how could I think about that from the equation itself? Well, if I can put in any x, when I square a number, it always has to come out positive, right? Negative times negative will be a positive. A positive times a positive will still be a positive. That's why we can see our graph is always in the positive y values, because no matter what type of x I put into it, whether it be a negative number or a positive number, when I square it, the negative and the negative make a positive, or the positive and the positive make a positive. So no matter what I do to my number, it has to be positive, unless for some reason I put in 0. So the smallest number I could get out would be 0, and every other number is going to be some number that's positive. So again, our y values could be 0 or a number bigger than 0 that is positive. So your task in making sure that you're on the same page with me is, first of all, you need to know the definitions of all of the important characteristics. So all of these definitions, you need to know all of them. But you also need to memorize those facts about the parent function. So you need to know what the word, for example, you need to know what the word increasing means. But then you also need to know when the parent function is increasing. So you need to memorize all of these words, but then you also need to know all of these facts. Now, just to help us with our vocabulary one more time, I'm going to come up here. I'm just going to do a random parabola and redefine those words as well. So the one that I'm going to choose to do is I'm going to choose to redefine all those words again for this one here. So the first most important thing is, where does this parabola turn around? So the vertex is right here. That's the point -1, +3. Now, for the roots or the zeros or the x-intercept, there isn't any. It never touches the x-axis, and there is no x value that causes the y value of 0. Now, I kind of went out of order. The axis of symmetry, what line would I draw this, or through this parabola to make an even figure on each side? Well, I'd put it right here. I'm going to label that AOS. So the axis of symmetry is this vertical line, which is always an x equals line. And what is the x-coordinate on this line? Well, that x-coordinate is -1. The y-intercept of this graph is where the parabola crosses the y-axis, which is right there. So that point is 0, 5. Now I want to ask myself, when is this function increasing or decreasing? So I always start on the function, and if I move left to right, it means I'm going to go this way. So here I'm going down, still going down, still going down, still going down. Here's where I switch. And after that vertex, I'm going to start going up. So when is my graph decreasing? Well, that graph is decreasing whenever I choose an x that's on this side. So this x value right here is -1. So anything to the left of -1. So anything less than -1. My graph would be going up, which is increasing, whenever you pick an x value that is greater than -1. Now, if I think about the domain of this function, what x values are on this graph? Well, I think everything, right? The x value of 0 is on this graph, the x value of 1, 2, 3. Now, this means it's just going to keep going forever and ever and ever and ever. Same thing with this direction, forever and ever and ever and ever. So I think the x's that could be plotted are all of them, all the real numbers. And the last thing that we'll do today is we'll look at our range. So the range is all the y values on the graph. What I notice right away is there's no y values or no points below here. So that line is the y value of 3, right? Remember, the vertex is the lowest point. So if the vertex is the lowest point on this graph, then all the other points have to be bigger than that. So my range, all the y values on my graph, the lowest one is 3, and all the other points have a y value that's bigger than 3. So again, just an extra example of seeing how we'd ask you to use that vocabulary.